Hi, in this lesson you'll learn more about class variables and methods. In a previous lesson, you explored the book class and the library class. Both of these classes had instance variables and instance methods. As a reminder, instance methods can only be called using the objects that you create from the class. In addition to instance methods, a class can have class methods. Class methods are methods that belong to the class itself and can be called without creating an instance object of the class. And just like a class can have both instance methods and class methods, a class can have both instance variables and class variables. Instance variables belong to an object. Each object has its own copy of the variables. Class variables belong to the class. All objects share a single copy of a class variable. Class variables are often used to keep track of statistics for objects of a class, accumulate a total, or store constant values that all objects need access to. Let's take a look at an example to see how you can use class methods and variables. Imagine you have been hired by a musician to write a program that stores the data for all of their albums. You want to add some functionality to the program so that it keeps track of the total number of albums the musician has published. In order to calculate the total number of albums, you will need to use a class variable. This is because the total number of albums belongs to the album class as a whole rather than one specific album object. Here is an abbreviated version of the album class. Right now, there are two instance variables, title and year, a constructor, and two instance methods. These will all belong to the album objects that are created from this class. Let's now take a look at the structure of a class variable. You declare a class variable in almost the exact same way as an instance variable. You include the visibility, data type, and variable name. The only difference is the additional keyword static. The keyword static designates the variable as a class variable. So let's add a class variable to the album class. You start with the visibility. Just like you typically have instance variables be private, class variables will typically be private as well. Next comes the important part, the keyword static to designate this variable as a class variable. This variable will store a whole number, so the data type will be int. Let's name the variable num_albums. You also know the starting value should be 0, so you can go ahead and assign this variable a starting value of 0. Now, you want to add 1 to this variable each time a new album object is created. Well, that's whenever the constructor is called. So, you can add the code num_albums++ to the constructor. Now, every time a new album object is created, the num_albums variable will increment by 1. Let's add a method that you can use to access this variable. Because this method isn't tied to a specific object, you can make this a class method. A class method signature looks almost identical to an instance method signature. It includes visibility, a return type, a name, and parameters. Just like a class variable, the only difference is the static keyword, which designates the method as a class method. Alright, back to the album class and class method. Let's make the visibility of this method public so that it can be called from other classes. Then you include the keyword static to make it a class method, followed by the return type. Because this method will return the value of num_albums, the return type is int. Let's name this method getNumAlbums. There are no parameters, so you can have an empty set of parentheses. Inside of the method body, you can include a return statement to return the value of num_albums. An important note here, class methods can access and/or change class variables, just like instance methods. Here, the class method getNumAlbums can access the class variable num_albums because they all belong to the same class. Now that you have a complete album class, let's see this program in action. At the top is the main method that will run the program. Let's trace through code line by line. The first line of code creates an album object, assigns initial values to the instance variables title and year, and then adds 1 to the class variable num_albums. The second line of code creates another album object, assigns the title and year instance variable values, and adds 1 to the num_albums class variable, making its value 2. The last line prints out the total number of albums by calling the class method getNumAlbums. Remember, to call a class method, you use className.methodName. The method getNumAlbums returns a value of 2, which is printed to the console. So that's the basics of working with class methods and class variables. In most ways, they function similarly to instance methods and variables, but since they belong to the class and not an object, you have to pay attention to how you use them and what they can access. As you've seen, class methods can access and change class variables, and they can call other class methods. This example is an extended version of the album class that includes code to track the number of gold and platinum albums. Take note of the class and instance variables at the top. Here, the class method getNumAwardsAlbums is able to call the class method getNumPlatinum and the class method getNumGold. Additionally, both of these class methods are able to access the class variables. On the other hand, class methods are not able to access and change instance variables, or call instance methods. Here, the class method isSameYear attempts to compare the years of two different albums. Logically, there's already an issue, but the program won't even get that far. A compilation error will occur that says non-static variable year cannot be referenced from a static context. What this means is that the instance variables or non-static variables cannot be accessed by a static class method. A similar error would occur if you tried to access the instance method getYear. This time, the error would say non-static method getYear cannot be referenced from a static context. This actually makes sense. Class methods belong to the class and not individual objects, so once the objects are created, a class method itself has no way to sort through them, pick one, and see its unique attribute values. Compiler error aside, there's also a logical error here. The method isSameYear is trying to compare the years of two different albums, but as written, the computer is left wondering, which album's years are these referring to? There may be 20 different album objects in the program, each with their own year. Thankfully, there is a way to use instance variables within a class method that doesn't result in these errors, and that is to bring in objects as parameters. A class method can access or change the values of an instance variable if you pass an instance of the class, the object, in as a parameter. Now this method can access the instance variables of the parameter objects as well as their instance methods. A couple last notes. Just like instance variables, class variables can be declared final. This means the value cannot be modified. In this example, the class variable artist is declared final. This sets the artist as the weekend for all album objects. It means this value cannot be modified. Similarly, just like instance variables, class variables can be designated as public as well. If you want to access a public class variable, use the structure className.VariableName. Now that you know more about class variables and methods, it's your turn to create and use them in your programs.